Good evening, Doctor. We are from Group 5 and today we are presenting about LPG gas storage and reticulation system in Arked Cengal. These are my group members. Me, myself is Alisha and followed by Adlan and Alifa. We decided on a centralized storage strategy located in a service yard. This decision removed highly flammable individual LPG cylinders from the commercial premises, vastly improving safety, reliability, and ease of maintenance without disrupting the stall operation. For our project, our objective is to design a safe and efficient LPG reticulation system. Secondly, is to ensure compliance with MS 830 and MS 930. Thirdly, is to determine the optimum LPG storage capacity and gas demand. Next, we also need to select a suitable pipe size and materials for our system. Lastly, we need to prepare engineering drawings like isometric drawings and system layouts. So for scopes, we need to have a site survey at the Arked Cengal and equipment identification. And secondly, LPG storage and system design. Thirdly, pipe sizing using branch and pulse method. And lastly, all the system and design relate to compliance with MS 830 and MS 930. To design the system, I assume that the diameter and the length for C14 portable baseline and the C50 centralized target. So diameter and length, and then I can find the area of the both storage tank. So area of C14 I get 6082.12 cm square, and for 50 I got 14,878.58 cm square. So for both of the area, I can get the ratio and I can get the evaporation rate, which is 40,878.36 BTU per hour. Then we calculate the demand for the 8 specific stalls, which gave us a total estimated demand of about 817,567.2 BTU per hour. However, by applying a commercial coincidence factor, we determine our actual effective load is 416,223.46 BTU per hour. To meet this demand efficiently, we optimize our storage configuration for a 5-day refill cycle. So this requires exactly 8 cylinders, which we have organized into 3 manifold banks, because I assume that one bank has 3 cylinders.
Next, on this slide, we can see the schematic drawing layout of our LPG reticulation system. Starting from the left side, this is the LPG storage area where the LPG cylinders are safely placed, and this location is positioned away from the occupied areas to comply with the safety requirement. Next, for the LPG, then it flows through the main pipeline network, which is distribute gas to each of the stall, and each connection is equipped with the isolation valve, and it allowing individual section to be shut off during the maintenance or the emergency without interrupting the entire system. And the layout also show the location of the storage room, toilet, and entrance to provide a clear understanding on how the gas piping is routed through the building while maintaining the safe operation. Overall, this schematic demonstrates that it was organized, efficient, and safe LPG distribution system that ensure a reliable gas supply while complying with the MS-830 and MS-930 standard.
So this is the isometric drawing for Cengal project where 3 manifolds bank housing the 8-cylinder calculated for the 5-day effective load cycle.
For the key operational safety requirement, based on MS-830 and MS-930 standard, first, the storage. The LPG cylinder must be installed outdoor in a well-ventilated area while maintaining the required separation distance from the building and the ignition source. Second, the security. The storage area should have a lock fencing with a clear warning sign to prevent the unauthorized access. Third, fire protection. A portable fire extinguisher must be available near and all the potential ignition sources should be eliminated around the LPG installation. Next is a pipeline. The gas pipeline should be constructed using approved corrosion-resistant materials and protected against mechanical damage to ensure that its long-term reliability. For the pressure, regulators are installed to reduce the height cylinder pressure to a safe operating pressure suitable for the appliance for each stall. And commissioning require a pressure testing and leak testing before the system put into the operation to verify the installation is safe. For the maintenance, it involves a regular inspection of cylinder, regulator, valve, and the pipeline, which a proper documentation to ensure the system remain in a good condition. And finally, the operation. It emphasizes that all operations should receive emergency response training and it follow proper LPG handling procedure to ensure that it was a safe daily operation. And together, this measure that ensure that the LPG reticulation system is operate safely, efficiently, and it complies with our national standard.
For reticulation system, I use two methods, which is branch method and pulse method. So branch method is to translate the gas demand into volumetric flow, and pulse method is to calculate the precise pressure drop across the pipes. So for branch method, I assume that the pressure drop is 4.2 inch WC, and for pulse method, I assume that the supply pressure is 0.5 psig, the maximum allowable pressure drop is 3000 Pascal, and specific gravity is 0.6. For branch method volumetric flow conversion, I will calculate the calorific value first, which is the CV baseline. So I got the CV baseline is 2019.7 BTU per feet cube. So for the list of the stalls, here has the 8 stalls, which is the Dean Corner Tom Yum Nasi Belauk, Mahmud Azmin, Makan Makan Cafe, Cave Western, and Cave Catering, Khalisha, and Cafe Al Rizik. So this is the flow rate where it's stated in the slide. This is the overall results that get from the calculation for branch method. Next is pulse method. So in pulse method, we will be using this equation, which is Q equals to square root delta P times D power of 5 over K square times S times L. So delta P is the pressure drop, D is the inner diameter, K is the constant, S is the specific gravity, and L is the length, and Q is the flow rate. So this equation, we need to calculate the Q, K, and delta P. This is the overall calculation result for pulse method from the node 1 to 2 to 1 to 9. So as we can see from here, the actual size of the pipe is 3/4 inch, and for the pressure drop, we can see that it's gradually increased. After mapping the pressure drops across all nodes, our terminal node for node 1 to 9 experienced a peak cumulative pressure drop of 937.59 Pascal, which the node 1 to 9 is the furthest stall from the source of the LPG. So this is well below the maximum allowable limit of 3000 Pascal is structurally verifying our system.
So for the conclusion, 416,000 223.46 BTU per hour effective load dictate the creation of a 3-bank 8-cylinder C50 manifold with a 5-day cycle, which are this specific load force through a 3/4 inch primary and half-inch branch network generate a terminal pressure drop of 37.59 Pascal, where the mathematical harmony, the storage capacity is perfectly optimized to meet the effective load without overpressuring the pipeline or starving the terminal branch. So for the final system specification and compliance, regulatory checklist is compliant with MS 830 and MS 930 standard. Emergency shut-off valve and pressure regulator structurally verified, and the spec panel is total demand capacity is 817,567.20 BTU per hour, where the effective operational load is 416,223.46 BTU per hour. Storage array, where there are 8-cylinder and 3 manifold bank. Refill cycle optimization is 5 day, and the reticulation system successfully replaced volatile portable setup with a mathematically optimized, continuous, and highly secure LPG distribution network for Arked Cengal.